What I've bought here is a pipe flange. A pipe flange is used for God knows what, but it's big, it's thick, it's solid, and it's almost 2.5 inches, which means it'll fit around the axle tube and take the place of a die to press out the axle tube from the housing. Now this is a 2 1/4 inch pipe flange, or 2 3/4 inch, I'm not really sure, but it's 2.44 inches in diameter, and I need to widen it out to just over 2.5 inches. Now, I've checked the dial indicator, and this isn't quite centered, but it doesn't really matter because I don't need accuracy, I just need this to fit over. So here we go. Okay, so we need to go another 20 thousandths. So that looks good. I'm going to take a little bit more because I don't want it to be a tight fit. Okay, so I'm just going to double check this with the dial bore gauge because I don't feel like doing this again if it's too narrow. I mean, I could just take off a bit more, but I'm very interested to know how accurate this digital vernier gauge is. Here is my high gauging super fancy digital vernier gauge, and what you want to do is first of all set the calibration. And as you can see, that's right on. So this is I think this is 1/20,000th of an inch, which is about 1 micron, which is typical for these sort of gauges. So now I'm going to open it up to 2.5, just over 2.5 inches. And then I'm going to do this. So this thing is supposed to work. Now, I've never actually done this before. This is the first time using a dial bore gauge, so I'm very interested to know how accurate it is and what the tricks are. So apparently you're supposed to put it at a little bit of an angle and then turn it up. And that's supposed to give you a good reading. So this is 2.50675. 2.505, 2.5025, 2.5056. That's more or less repeatable. Let's turn it and then try it again. See, now I'm getting 2.50. Okay, it's slipping. So I've got to tighten it a bit more than that. But now I'm getting under 2.5 inches. Two 2.507, 2.508, 2.50765, 2.507. So I think 2.507 is what it seems to be averaging out at. And this is giving 2.510. Two point five 2.510. So this is about 3/1000ths of an inch over reading. So I think I'm going to take off a little bit more and consider it a day. So now it's 2.519. Two 2.51915. Okay, so the bottom is now slightly wider than the top, and that's fine. So here is our bored out flange, and this should be perfect for pressing out the axle tubes from the pumpkin. So I mean, you can see how thick this is. It's a monster piece of metal. So this basically cost about 10 or 15 bucks on eBay. It's a used flange. This is a cheap boring bar, but it's got quite a nice insert. It's got a tungsten carbide insert, which cuts very, very nicely, especially into the soft material. So I wasn't impressed with this boring bar because it's not very rigid. You get much thicker boring bars actually, but when you use it with a very short length like this, it's just perfect, and the sharpness of the tungsten carbide is just really a pleasure. So before I go, I'll just mention this dial bore kit. So this was about 20 bucks on eBay. It's a Chinese kit. It was sold as an eye gauging kit. I flagged the item as a fraudulent copyright infringement or trademark infringement. These are not very good quality, but they seem to do the job, and I mean, I don't really have any problem paying $20 for something that works kind of okay. I've never used one before, I never owned one, so I thought it was well worth trying it out. So that's how you use a dial bore kit. So that concludes my boring video. Hopefully it wasn't too boring.